Suppose you run one full lap on a track, 400 meters. You're out of breath. Your watch says 400 meters distance. But physics asks, where are you now compared to where you started? Answer, the same place. So your displacement is 0. Strange, isn't it? You moved a lot. And yet, in another sense, you didn't move at all. Let's define this carefully. Distance equals to how much ground you covered. Always positive. Displacement equals to how far you ended up from the start, with direction included. Example: walk 3 meters east, then 3 meters west. Your distance? 6 meters. Your displacement? 0. So distance cares about the path. Displacement only cares about the starting and ending points. Now, if you divide distance by time, you get speed. That's what your watch or your car speedometer shows. It doesn't care about direction, only how fast. 100 meters in 50 seconds means speed equals 2 meters per second. But if you divide displacement by time, you get velocity. Now, direction matters. Let's make it simple. Suppose we call east the positive direction. Then automatically, west becomes negative. So, go 100 meters east in 50 seconds. Velocity equals 2 meters per second. Go 100 meters west in the same time. Then velocity equals minus 2 meters per second. The plus and minus are not good or bad. They just mean which way along the line you chose. And later, in 2 dimensions, we'll do the same trick. Use plus and minus to mark directions on x and y axes. Same logic, just more arrows. Run a full lap again. Distance equals 400 meters. Displacement equals 0. So average speed is not equal to 0, but average velocity is equal to 0. Both are real. Both are physical. But they answer different questions. Distance matters when you ask, how much did your legs work? How much energy did you burn? Displacement matters when you ask, where are you now compared to where you started? They are not competing ideas. They are complementary, like 2 different lenses looking at the same journey. So, speed from distance and velocity from displacement are both physics. If you're an athlete, you care about distance. If you're a navigator or an astronaut, you care about displacement. Physics isn't choosing one over the other. It's giving you the right tool for the right question. That's the beauty. The world is richer than a single answer. Now, why does physics lean on velocity then? Because the next big question isn't just, are you moving? It is. Is your motion itself changing? And that only makes sense. when you track both size and direction. That idea, the change of velocity, is what we call acceleration. And that's where the real fun begins. This was Stickman Physics Lab, where physics is simple, clear, and fun. See you in the next episode.